Okay, so we'll go ahead and get started. Thank you everybody for joining us. My name is Maria Emanuel. I'm the Associate Director of UNH Innovation. This is our usually monthly Catalyst Seminar, and it's our second of this academic year. And we have a theme this year, what we call a conversation about. And the idea is we wanted to bring together experts. So we wanted to have experts talk to us about different topics, those who are in the industry, and then those who come from the research space. And to look to see what some of the innovations are, some of the challenges, how problems are approached, to think about ways that we can exchange problem-solving skills and capabilities to advance various interests. And so we're really excited to have this presentation today specifically, and I'll introduce our speakers in just a few moments, and to give this idea a try to explore these areas of interest and mutual interest. So our next, to do some housekeeping, our next seminar is going to be November 19th, and we'll be here again at the Alpha Loft, and we will be announcing shortly what our discussion will be about and the speakers for that. We'd like to keep it a surprise. That way you keep checking back and so forth. So I want to thank our sponsors for today, which is Upton and Hatfield, a law firm providing legal services to people, businesses, and municipalities in New Hampshire. We appreciate everybody's attendance today. There's a networking event after this here. Please help yourself to beverages and to snacks and to stay afterwards and to continue the conversation. Just remember, you need to be 21 plus. Looking at all of our young folks here in the audience, but 21 plus to have the alcohol. And looking at you, and I'm looking at you, Patrick. Oops, and I'm supposed to be holding this up. I didn't follow the rules, sorry. So what else? November 4th, we have a new event that we're trying at UNH, and it's called the UNH Aerospace and Defense Day. And it's a way to bring together kind of this audience, so those who are in government and industry and research, and to talk about things that are interesting to you and that might be of interest to others. And so we've picked this theme of aerospace and defense, and we're extremely happy to say it's sold out. It's not even the day before the event, and so we're quite thrilled. And what we hope to do is to find other topics that we can have similar types of events where we can bring together all these different interested parties to showcase UNH resources. There will be some facilities tours as well as researchers being able to talk about what they do, and then speed dating, because everybody likes to have a speed date opportunity. So we're going to do speed dating, and then as you hear about things that might be of interest, you can make connections. We'll let you know how it goes if you weren't able to attend this one, and if there are topics that are of interest to you, we'd always love to hear what that might be. So I think that's it for housekeeping. I'm looking around. Nobody's telling me I forgot something. So we're going to move on to our seminar. I'm really thrilled today to be able to introduce our speakers who will be talking to us about wireless connectivity and the Internet of Things. So first we have Steve Perlberg. And Steve is the manager of M2M IoT, which I now know means machine to machine and Internet of Things partnerships at Verizon Wireless for New England. He has over 20 years of cellular experience with Verizon Wireless, and his current role is to onboard companies that want to become part of the Verizon Wireless Partnership Program by utilizing lots of letters, Verizon Wireless M2M ecosystem. Okay, thank you. I know, put the life scientist up front. And we also have Nick Kirsch joining us today. And Nick's an associate professor in UNH's Electrical and Computer Engineering Department. And I know you're going to tell a little bit about yourself. So his expertise is he's an electrical engineer with research interests including, and I will read every word of this because I can't do it otherwise, multiple input, multiple output communication systems, wireless sensor networks, cognitive radio, software-defined radios, transparent antennas, and spectrum sensing technologies. Perfect. Thank you. And because he has extra time on his hands, Nick has just started the Connectivity Research Center, which is a brand new organization on campus. It's a really exciting opportunity and performs networking engineering and cybersecurity research through partnerships with government, industry, and academia. And we'll be hearing more about that as well. So what we're going to do today is to have Steve present to us first for about 20 minutes. He has some slides. He wants to share some, roughly,
Yep.
Yes. Some slides to share with us, and then Nick is going to present, and then we'll have we'll be able to relax, have everybody sit down, and then we want to open it up and have a dialogue and a conversation, questions that you might have, related experiences, things that we can discuss, and ways to think about connections, because we're talking about connectivity. So with that, I'm going to turn it over to you. Thanks, Steve.
I'm all about dialogue, so I get tired of hearing my own voice. So at any point through the conversation, just ask questions. I'm fine with that. So again, Steve Perlberg, live in Southern New Hampshire, and been with Verizon for over 20 years. So I appreciate everyone letting me come in here today. So my team, so I run the IoT system. What is that? IoT, Internet of Things. You can look that up. It's still very vague, you know, but the year 2020, the industry is expecting to reach 50 billion connected devices. Obviously, cellular would love to be a big part of that, but it's not going to be. It'll be a percentage. There's different ways you can connect, and I'm sure Nick will go over that a little bit. You know, you've got satellite, you've got Bluetooth, you have Wi-Fi, you have multiple different options, and cellular happens to be one of them. The beauty of cellular is that you don't have to worry about the network. The network's already there. So what my team does is that we look for companies that want to be part of Verizon resale. A perfect example would be Redbox. Who's ever been to Redbox, where you go ahead and you get a DVD? That is using cellular technology. It's a credit point router, and they're using cellular technology to take inventory as well as to take point of sale, credit authorization. I was downstairs and just parked my car, and I had to go to that box. I had to, you know, it takes cash or it takes credit card, and instantly, I'm looking around to see how it's connected, to see if this little antenna. It's obviously hardwired. So for that type of solution, I know Durham here wants to be connected through a smart town, smart city program using cellular technology as opposed to landline. Really increases the point of getting those things installed. So another example of that we use, if anyone been in Boston or other areas, there's a company called Big Belly. Big Belly solar trash cans. All that does is lets the city or town know when the trash is getting full, so they can send out a truck. So instead of having to hire, being able to monitor things remotely is where we can come in. Right now, GSM, which is AT&T and T-Mobile, they've been doing this for quite a while. Verizon, being CDMA, has come on very, very strong. So what we can do is, and I'll get into a little bit, I have slides, but I like to talk as well. We get into, does the customer need connectivity? Yes, we can help them with that. So I don't know if anyone's been to our Innovation Center in Waltham, Mass. So there are 2 innovation centers in the country. One is in Waltham, Mass, which is this incredible multi-million-dollar facility that showcases all the different technologies. So Verizon is really looked at it as what's next. It's so big. I mean, I have companies that do cashless vending. That's got you put a Coke machine in the break room, and you want to take credit cards because a lot of people don't have cash on them. So what do? Well, you have to tell the IT guy that you're going to access his intranet. The IT person doesn't want anything to do with that. Plug and play using cellular, you're good to go. Cashless vending, alarm systems, home security is huge as well. So really what we've done, we've narrowed it down to 4. The smart city, that is huge. I mentioned Big Belly. All right, I just talked to a company today in Massachusetts that has a whole grid solution for traffic lights, being able to monitor traffic lights, huge. San Francisco right now currently has a company that 30% or maybe 40% of all traffic in a city are people looking for parking spaces. It's crazy, right? So what this company did is they have the meters using cellular technology with an app on your phone, and GPS lets you know where the nearest empty spot is. Brilliant, right? So a lot of things like that are coming into fruition. So we have smart city, we have healthcare is a huge play. Obviously HIPAA compliance is very important, but the ability for home patient monitoring is absolutely huge. Philips Electronics, just in the Andover area, is a huge player right now of these devices that you can self-monitor for patients. So instead of that caseworker knowing what the patient is doing, instead of the patient coming into the hospital, which can get very expensive, that caseworker can know exactly what's going on. I have 3 companies right now that are making a pillbox, 30 days. lets the caseworker know when the person's taking a pill or not, because the lid pops up. It's crazy. Healthcare, telematics, the smart car, right? Telematics is a huge, huge play right now for onboarding. And the last one we really get into, as I look at it as a utility, oil and gas space as well. Being able to monitor everything that's in the field. I mean, look at California right now with the drought, right? No one knows where the water is and what the water levels are is a huge play right now. And what I'm really seeing just recently is agriculture. You know, I was driving in here off 101, I saw the farmland out there. I was at a TEDx event, lucky enough to go to a TEDx event. You guys heard of those? They're pretty cool, right? TEDx event in Boston on Berkeley Street just a few weeks ago. And their company, Analog Devices, was there. And they have this whole thing. They have this display and they have this, they're calling it IoT tomato, and they're monitoring tomato plants for soil levels, the quality of soil and things of that nature. We have a company out in the vineyards out in California that's for wineries, monitoring the grapes. I have an incubator that I do a ton of work with incubators in the Boston area, so like Mass Challenge and Cambridge Innovation Center and Bolt and Techstar, Greentown Labs, all those companies that we work with, and what we're doing is educating these startups on what they can do if they need cellular connectivity, if they need somewhere to host. I got a company here in Concord that monitors propane tanks. Just lets the tank know when the propane tank is going low. Because anytime a truck needs, it's called a truck roll, and it needs to come out to that house, very expensive. Right? So if you want to host the information, we can help you with that. If you want to write the application, we can help you with that as well. My part is easy. I'm just the vapor, the cellular. I have 4 people on my team, as well as 4 engineers. They're the project managers. So to get into the partnership program, what we want to do is resell the service. Because really, as a Verizon company and all these other carriers right now, I mean, you guys are being bombarded every day with get a new tablet, get a new cell phone, get a new whatever, get a new jetpack. What's next for revenue for these companies is this machine-to-machine IoT space. Now, some of my connections, some of these alarm companies do such little data, 50 cents a month. But they're doing 10,000 connections a month. AVL GPS, vehicle tracking. You own a fleet of vehicles. You want to know where they are. Years ago, I was working with Lucent out of Boston, and they were having a huge issue with their union guys because they take the trucks home with them. And they had this motto called HBO, Home by One. And being able to, right? So, but if you didn't know where they were, then you wouldn't know that. If I'm a construction company and I have 10 vehicles, and I have this GPS, and I let my guys take the trucks home because it's easier to just get out on the road in the morning instead of going to a yard. And I happen to look up on a Saturday because it's all a SaaS model, and I see why is my car at Family Park right now on a Saturday. So AVL GPS is huge. Backup continuity. You have a primary retail location, and you lose internet. This is a true story. I was at Market Basket. Anyone here working at Market Basket? I was at Market Basket in London area a couple years ago. Had about $200 worth of groceries. Yes, I shop because my wife, with 3 kids, I think we talked about that. 3 dogs now. My wife just got a puppy, so if you guys want a puppy, it's more than yours. I literally said to her, do not bring home another puppy. I was running the Smutty Nose Half Marathon. We were leaving that afternoon. We were leaving at 3. She came home at 2 with the puppy. So I'm at Market Basket, and I have I've got it, and all of a sudden I see these guys running around. Remember the old knuckle busters for the old credit cards? I'm like, what is going on? They lost their internet connection. So they were doing manual transactions, and the lines were huge. I didn't have cash on me, so I just left it and went down the road to Hanford. And I grabbed the manager, because I'm like, what's going on? Because I'm just thinking now, he goes, we lost credit card. And when you do a manual input, your discount rate is higher. You're talking less than $50 a month to have backup continuity. Actually, a lot less than that. And they were losing thousands of dollars. So IoT, what is it? There's a lot of things out there. It's what can you do? We did a thing at Gillette Stadium earlier this year where we had an IoT job. And someone said, IoT, if anything, if you have a business and you can think just a little bit differently of what your needs are and how we can fix those needs, then we've helped you out. right? And there's so many IoT committees going on. I sit on 2 IoT committees in Boston right now trying to figure out what's going on. I had a meeting a couple months ago with the president of the university and some other people, because they really want to make UNH the center for smart city as well as innovation to keep this moving forward, right? These students that are leaving to go to other schools, they want to keep it here. So I love the fact that I can help out with this, right? I mean, I grew up in Mass, but I live in Windham, New Hampshire right now. I don't know where there is right there. We represent. So I'm not really going toward my slides. So the slides I have are part of the Innovation Center that we have in Waltham, Mass. Oh, and by the way, if you take a box, like this in-focus machine, you want to make that, oh, here's a perfect example. So Yankee Candle, right? We all have Yankee Candle. We worked with them. They have a wireless Yankee Candle box, you might know it's a box, that they set up in hotels. Psst, just sends out a mist. And it's using cellular to let them know when the mist needs to be filled up, right? It's crazy. We have a data lab, but when you take a black box and you want to make that connectivity, then you need to use a cellular radio, which we have relationships with all the major manufacturers, from the Telets to the Cellular Wireless, and you put that in that box. That needs to go through what we call our OD, our open certification. Takes a few months, maybe actually less if you know what's going on. 90% of that certification is getting the antenna right? That antenna, that RF design is half of it. Once you go through that certification, so what happens now is that Yankee Candle is part of my partnership program team. I'm billing Yankee Candle, whatever negotiated rate. Yankee Candle then is selling that service in that SaaS model back to the Hilton or Sheraton's, whatever it might be. That's what I might do. And every year my budget gets doubled, it seems like. But more and more companies are going toward the ability for this remote connectivity. I'm dealing with a company in Boston right now called Dip Jar. You go buy coffee, right? You want to give a person a tip. You don't have cash. It's a little cylinder about that big. You just tip $1. They're blowing up. Who would have thought? Who would have thought? Yes, please.
And are there, in the case of Yankee Candle, are there fees per month for the contract, or is it just data per device?
So yes, look at it very similar to a cellular rate plan. But we negotiate a plan, and it's not based on minutes of use, it's based on how much data they need. Something like Yankee Candle needs less than a meg. The least I can do is 1 meg a month. I can't do kilobytes, I should say. So yes, so it's per month that we're charging them. So if it's $1 a month, and they have 100 candles, 100 sensors, that goes from there. And a lot of that is based on more data. Now, what I need to do, because $1 was great, but as revenues, budgets increase, I need to find those higher bandwidth opportunities. So I'm sure you guys have all seen the 4G LTE. That's been thrown down your face probably for 3 years by all the carriers. 90% of all of these applications or examples I gave you guys are on 1X or 2G. How much data do you need to send a little signal once a day? You don't need it.
Is there also a fee per month, a monthly fee that's on top of the data?
Well, so the partner, like a Yankee Candle, is charging, I don't know what that is charging a fee to the Hiltons and the Sheratons for their service. So they're not charging a cellular fee. They might be saying, hey, for $25 a month, you can have this program. And then that $1 that I'm charging them is built in. That make sense?
Yeah, but you aren't charging, but the cellular provider, though, they aren't charging a monthly fee, are they?
We're charging the monthly fee to Yankee Candle.
But is it just for the data?
Just for the data.
Okay.
Only. That's it. I'm just selling data. I'm selling a mobile number and a static IP address. And we build private networks because a lot of these, like in credit card, PCI compliance, we have private networks that we build. We have Terramark cloud services. Verizon has spent billions of dollars on network infrastructure. When we purchased 700 megahertz, which is LTE, we purchased Terramark, which is a world-class cloud services company. We purchased Cybertrust for security as well. We also purchased Hughes Telematics, which used to be a huge, well, they still are a huge AVL GPS. We're white labeling it and calling it Network Fleet. That's just that GPS. You have 10 vehicles, you want to go ahead and connectivity, go from there. Yes, please.
Steve, are you enabling partners? Is that what the focus of your team is? Or
That's exactly what I do.
Okay.
So I'm responsible for onboarding new partners. We call them hunters. My team goes out there and they hunt for new opportunities.
Okay,
so
and they primarily embed your service, any services that Verizon has in their actual product offering.
Yep. Primarily what my team does is to resell for the connectivity. If they want cloud services, like for example, Yankee Candle wanted connectivity. Big Belly, they wanted connectivity, so we work with them through our OD labs, sign them up with a contract. Now we're billing them a monthly data fee, which then they're either eating, but for resale, they're then selling the entire service. That's exactly right.
So you're looking for value-added resellers.
Yep, they're reselling. Now, legally, they have to do this to be part of this program. And yes, please.
So downstream in some of the more complex connections, do you see a bandwidth capacity issue? And is the private sector solution different from the government solution?
I have very few government solutions.
Yeah.
With the ones I do have, I mean, some companies that sell to the government, like I have a company called TrafInfo in Woburn, Mass, that has a black box that measures that they sell to the DOT to count the cars. Simple as that. So the government space, now we have a whole team dedicated to the government space, and they can use these companies like TrafInfo to present to New Hampshire and Mass and really countrywide. Yeah, but bandwidth is not an issue whatsoever. I was saying before, 90% of my connections are on the lower bandwidth. I need to find the bigger ones, like video monitoring. You're a security company, and someone's paying you a lot of money for those cameras to monitor. Usually they're in office parks, things of that nature. Construction sites are huge because of all the theft. People stealing tools, people stealing copper. You put up a closed circuit television, and yeah, you can connect it to a Wi-Fi or an Ethernet, but where are you getting that connectivity? So cellular is an option for them right there.
So your interest is you're making the money based on the throughput that's coming through, whatever that application and device is generating.
Yep.
So the metric on the data is how Verizon makes its money.
Yep. So of course, the question I'm asking is how much data do you need? Tell me about your application.
So
how much data
so
do you
I might
need?
have a device that may generate 2 megabytes of data a month, and I'm going to bill you so much.
You got it. That's exactly right. Now, what I would love to see, I think the rate plans we still need to improve on them. I would love to see, I would love to be able to sell a company, you need a terabyte of data, here you go. I'm going to sell you a big block of cheese and you cut it up however you want, as opposed to trying to monitor it because it's difficult, because the problem is sometimes you get hacked. Now you've got massive overages, right? Now
the cost of monitoring it can almost be as much as the cost of running the device.
Exactly. So you see Terramark and Enphase, we combine them, and we have a machine-to-machine private network that's an online tool that lets you see all your devices, the mobile number, the static IP address, but more importantly, how much data they're doing. And you can set up alerts. Say that they get 5 meg a month, and all of a sudden it's the second week of the month and they're at 4 meg. All right, that's an alert. Something's going on. And all the data is pooled. So in case one goes haywire, the last thing I want is for the customer to get that experience. And it has happened. And we do the best we can for the credits and everything else. But having that management center is a huge asset.
So you don't care how many IP addresses, you don't care how many devices.
More the merrier.
If I had 250 devices, let's say, the issue is that the cost of between 50 and 250 wouldn't be a difference. What would be the difference is that it's simply that data block.
Yep. Yep. Usually the discounts start around 1,000 connections and more that they commit to, give or take, right? But, yes, please.
Does your team actually do the innovation side of it, approaching Yankee Candle with this wonderful idea?
That's exactly what my team does. So when I said they're hunters, they are prospecting. Okay. Now, to me, there's different ways of prospecting. Coming here today, being part of working with these Mass Challenge in Boston. We went to that event, just let them know what's going on. All of a sudden, we're being approached. There's a company in Mass Challenge right now called Pet Simple that's making a dog collar that's using GPS tracking. You name it, someone wants to put a connection on it and go for it. But yeah, so they're out looking for companies that can do that. That's exactly right. Yes, please.
I mean, just a comment. I think I can't remember the number. It's double digits. You're talking about the cost in healthcare is not being compliant with medications.
Yes.
So they're talking about physiologically a chip where you can actually measure the concentration.
Yep.
You know, that people are being compliant with medications.
That's,
It's
I mean,
like
the healthcare.
20% of the healthcare costs.
The healthcare is going to blow up. It's a question of how can we do it that's the most cost effective, and because then you're relying on the patient, right, to access that information, and you just take a best guess that that caseworker now is able to do it. I remember years ago I worked with Zoe Medical because they had they were selling EKG machines in ambulances, and they were connecting it with a cable and a cell phone. So that patient, the doctor in the emergency room. The doctor in the emergency room wouldn't have the readings of the patient before they got in. Yeah, I'm doing this a long time. I mean, I set up almost every police department in Massachusetts with the laptops. I set up UNH with laptops with the wireless connectivity so they can run plates. So if you get arrested, I apologize. So I have a lot more slides. I just want to have. I'm not really going through the slides. I think we're fine. That's kind of what we do. That's what I've been doing this now for about 4 years. It's fantastic. You get to see so many new technologies that are out there. You get, I'm trying to find the next Nest, things of that nature. Cellular is not always the primary. A lot of times, cellular is the secondary solution, and that's fine. That's fine. We just need a piece of it. Thank you, everyone.
See the beer and snack line got popular again. Please help yourself at it. Yeah, I'll try my best. My name is Nick Kirsch. I'm a professor here at UNH, and I'm going to talk to you a little bit today about wireless communications research at UNH. Feel free to stop me at any point if you have a question about something specific. I do have some students. I'm usually teaching a lecture right now, doing my graduate course on wireless communications, but I promise I won't get too technical. However, I'd love to talk about some of the specifics at any point. A little bit about me. I'm originally from Wisconsin. I went to the University of Wisconsin as an undergraduate. Yeah, Mark and I have that connection. I did my master's degree and PhD in Drexel University in Philadelphia, and I've been here. This is my 7th year at UNH. So I want to talk a little bit first about my traditional on-campus research that I have going on, and then I'll talk about some other things. And I think Stephen's introduction, or not introduction, but discussion about all the things that the Internet of Things can do, is pretty phenomenal. The story that I like, and that'll kind of segue a little bit into some of the themes that I think are important to also talk about when we talk about the Internet of Things, is this story of, there's water sensors now that are connected online, right? And you can have that on your house. And it's a really easy way for people to kind of monitor and determine what your water usage is without having to go out there, although sometimes now they still have to drive through your neighborhood. But then there becomes the question of privacy, right? So if someone can have a second by second or sub-second sampling of your water usage, and they see that suddenly there's like a 2-gallon spike and then it drops down, and then they'll say, okay, somebody probably flushed the toilet, but then right after that there's no slower flow turning on, like then the person didn't wash their hands, right? So right, so we don't want people to know that. So I think the flip side of it so the flip side of it is how not just can we make all these connections, but can we protect that data? There was the the recent incident with Jeep, and Jeep was in the news because of the Grand Cherokee suddenly could be taken over by a wireless hacker. It's interesting on campus, and not at the IOL, just off campus a couple weeks ago. Some of those engineers were actually there working on another project, and they said, actually, we solved the problem a year ago, but bureaucracy and marketing and hand waving and things kind of got in the way. But it's important. I think it's a really important thing that we kind of couple and keep in mind as we do those stuff. So those are my 2 funny stories to start. The UNH Wireless Systems Laboratory, what do I do? What am I interested in? Our research is really extending from the electromagnetics of radio wave propagation to the algorithms that control wireless networks. I'm really interested in, I started in how radio waves propagate through an environment, how antenna systems work, all the way up to how we actually control and use that wireless channel. And I think that's really one of the most important parts. The big push of Internet of Things is to get devices and put them everywhere, right? And to then take and create new technology that can utilize that type of information. I'm really interested in how we can get to those connections, how we can keep them secure, but we have to remember that we're still resource constrained, right? We only have so much wireless spectrum that can be used for a certain application, and we can only use so much power, right? If we're talking about wireless sensors, it's great if we can plug in a red box, but what if you are doing some kind of sensing application that's remote, that's battery powered, or it's not easy to give power to, right? So my interest in some of the work we do at UNH kind of balances those and considers how we do those two things. So I'll talk about a couple of interesting projects that we're doing on campus that sort of, reach through those different things. So one of the projects that's kind of neat is transparent antennas. Does anybody know why you want a transparent antenna? So you can see through it. So you could put it, yeah. I mean, that's the biggest reason, right? So you can see through it. Some applications might be, hanging in, instead of putting some antenna system mounting onto the ceiling or outside under the wall, could you just hang something in the window, right? Could you put an antenna in the window? So I've been, chasing this thing since I was a graduate student in Philadelphia. I was playing with polymers. I was way outside of my element. I kind of refocused when I was here, and we developed these antenna system. You can kind of see, sort of see that kind of grayish patch. So what that is that's just a piece of, basically like transparency, like a piece of plastic with 20 micron wide wires on it. Very thin wires in a small mesh pattern. And doing all the math and the computational electromagnetics behind it, we were able to figure out what a good size is, how we can set up the proper current distribution to get the antenna to radiate. So this is actually just like, if I had a piece of copper antenna. That's sort of what you see there. It's not the whole system, but I wanted to give a kind of a visualization of how transparent it could be. And it's more transparent than like a window screen. Like if probably, yeah, there's some there. You can hardly even tell the difference between the two, and it's more transparent than that. So this is a great enabling technology for putting network devices, wireless network devices in more places. Another application, a program that we have going on right now on campus is this wireless sensor network. This specific one, I'm partnering with a colleague in civil engineering, and we're trying to solve this problem of making more efficient building system, building energy systems, excuse me. The motivation for this is, does anyone in here not have a cell phone with them right now? 1, 2, okay, so we'd be off by 2. But basically, we all have a cell phone with us, so if we can actually count and localize that inside of a building, we can then more efficiently control the heating and cooling systems. So right now there's CO2 sensors, and really it's the fresh air that they're pumping in and out of buildings to kind of maintain their, the comfort of them. But if we can know exactly how many people are in a room, we can more accurately then control the heating systems. So we looked at a wide range of different technologies to use. We polled students, and they all carry cell phones. And your cell phone is occasionally paging information, little bits of data that say, hey, here I am, or this is my power level. And without there's no security breach. Really, we're just measuring the presence of that electromagnetic energy, and using some technology we built to then localize it, we can then say these people are in this area. So now we kind of have a proof of concept in Kingsbury Hall. It's our engineering building on campus. This is sort of showing regions of probability where different cell phone emitters are. And we're thinking, where can we go from there? Can we use this for other applications, maybe for search and rescue or for emergency situations where you may be able to detect that signal? And there's a broad range of things. And one of the unique aspects of this has to do with detecting energy, detecting wireless energy, detecting spectrum. The last topic I'm kind of going to highlight here, and what it is, I didn't have a picture of it. It's hard to have a picture of measuring wireless spectrum. But this is showing, just from a paper of mine showing that we can denoise a signal and we can figure out where these bands are. So I mentioned a moment ago that wireless spectrum is a resource, right? In order to transmit information over the ether, we need to use some bandwidth for our signal. And one of an enabling technology for the Internet of Things, for higher bandwidth devices, is this concept of using underutilized spectrum. So right now, at any place, on average over the United States, there's only about 15% of wireless spectrum being used at any one time. Right? So, there's probably not an emergency call. A big one is big blocks of spectrum that are used for radar systems for military applications. So maybe, we're not that far from the seacoast, so there could be some radar activity, but likely there's not. So likely there's all this bandwidth that's available that's prime for wireless connectivity that's not being utilized. So an enabling technology is what we call cognitive radio, where if we can sense whether that spectrum is available or not, can we then use it? And that's sort of the motivation for this work. And there's been, people have kind of beaten this to death in the early 2000s over ways of doing this, and they kind of hit a wall. And there's the fundamental wall is, if you know what you are looking for, it's not that hard to find. If I know I'm looking for a TV radio signal, I can find it. But if I'm looking at over an arbitrary band with an arbitrary signal that's being transmitted on it, it becomes a very difficult problem, especially when the power level is low. And that, where a power level is low at one end of a connection, it may not be the same at the other end. So you may be causing undue interference if you then use that. So my interest in the graduate student I'm working with is to develop new ways of accessing spectrum that may be available, and we don't know if it is. Okay, so some quick facilities if you're not familiar with what we do at the WSL. We have something called an anechoic chamber. This is a quick photo of it. My wife calls it the chamber of secrets because when I'm working in there, my cell phone doesn't work because the door's closed and no wireless signals get out of it. It was a big problem when I was in graduate school. I spent all my time in one. But the idea is here we have the capability to actually model or simulate. Well, we can simulate, but then actually measure antenna radiation patterns in wireless systems. It's a little hard to see. I couldn't find the one that was a little better, so I took one this afternoon before it started raining. This is Kingsbury Hall, and we have I think the total height is 130 feet, 170 foot antenna tower. There's 3 antennas on it right now. So we have capabilities of actually deploying and putting wide area networks on campus. And then some of the places that supported the facilities and the work we do at NSF, UNH, and Institute of Electrical and Electronic Engineers. So that's kind of an overview of some of the things that I do and have been doing over the last few years. And I recently had an opportunity to take on a new challenge, which is what I want to talk about today as well, called the Connectivity Research Center. Our motivation is to creating a connected world. As I said before, the core of wireless communications in general, is the access and the use of this resource, the power and the spectrum. And on campus, I'm assuming a lot of you have heard of the Interoperability Laboratory, the IOL. Okay, so they saw a need based on their partnerships with a lot of groups in industry to do research. And they were trying to figure out a way that they could motivate that work to be done. And they asked me to sort of take over this effort and then to kind of bring together faculty to create some interesting collaborations to then do some great work. So essentially, this new research center grew out of the need for network engineering and cybersecurity research on campus. We have a lot of faculty that do some interesting work that kind of touch on those themes. And the goal here is to bring everyone together to partner academia with industry and the government. We have a couple of projects that are starting right now, looking at different kinds of wired networking solutions, actually, and some more traditional network protocol type work. And we're also looking in kind of coalescing around a big theme, which was mentioned by Stephen. And we're looking at building a smart town, right? So when we talk about wireless communications or connectivity, we're talking about this middle part here, this networking part, this part in the middle. How do we make those connections? How do we manage the resources? How do we create technologies, the antenna systems or the spectrum sensing technologies that can enable a large number of devices to be connected. The challenge going forward, and I'll list a couple of the big challenges, but one of the challenges is how do you get billions and billions or millions in a small area of devices all to cooperate or to work together, right? A colleague of mine said to me, the Internet of Things is going to break. It's going to break wireless spectrum. Everyone's going to interfere everyone to a noise level that's just intolerable. It's an interesting problem, or an interesting idea, but I think if we're smart about the way we tackle it, we can do some pretty neat things. So one of the reasons for the Connectivity Research Center to take on this theme of smart towns is there's a big initiative by the US government to push into smart connected cities. So we're looking at doing that. We also have a lot of people on campus that do some really interesting work that we feel could make use of that. So if we have our town at the bottom, so it's a little crude, I don't have a big marketing group yet. So if we have town, if we have Durham, Lee, Madbury, the surrounding area, maybe out to Portsmouth, and my idea is that we have connections here on campus to those. Obviously, we're in Durham, but we have connections to those municipalities, to the people who work in those places, the police, the fire, other types of entities that we can then kind of bring together. And then we have faculty on campus that do all kinds of sensor work and may say, I'm developing the sensor technology possibly to monitor the blood, the levels of different kinds of drugs in their blood, right? But then, what do you do with that? How do you get that out? How can you then connect that? And as we have established before, wireless networking, the work that I do, kind of fits in the middle along with other faculty. But then you have all this data, right? So if you have thousands, billions, millions, whatever the number is over some area, how do you analyze that data? How do you actually find the needle in the haystack? How do you then optimize your system, right? And the goal is to then bring in some faculty on campus that do data analytics and other types of work that can make use of that. And then you have, the high level layer, the applications. And I think, as Steve was saying, their big business right now is to go out and say, this is the technology we have. Let's think about all the great things we can do with it. And on campus, we have these people. We have people that I've been talking to that say, okay, well, I would like to set up this system that's 9, 10 miles off the shore, and I need to connect in order to get my data back. Or I'm doing some research on streams and tributaries that are kind of in a remote part of the state. How do I get my data back? I'm working on a project, we're trying to work on a project where we're setting up thousands of wireless sensors in the Arctic region. So how do you move that data? How do you get that data from one place to another? Although that's not in town, right? What I'm trying to do is give you the idea that there are, in fact, a lot of interesting applications. And that's where we saw the benefit of sort of rallying around this theme on campus as a way of applying for some interesting sources of funding and to really make great technological improvements right here in Durham. Some of the questions that I ask, and if you were to talk to anyone, any person that may fall in one of these layers, of course there's going to be all kinds of things and questions that sort of pop up. Things that I'm considering is, how do we connect millions of devices in Durham, right? If your pen has a connection, if this has a connection, sure, could be all very low bandwidth devices, but in aggregate, this could create a lot of interference. Another question that was brought up: how do we serve different kinds of bandwidth, right? So a lot of the red box type thing application is going to use 1x or the 2G model. Whereas streaming cat videos on your phone in HD is obviously going to be more of an LTE type of thing. That's funny. We're not a cat video crowd? Okay, all right. Not a cat video. What kind of 2 minutes? Okay. So how do we serve those different kinds of bandwidth? And it's not clear to me that there is one solution for all of that, right? I think it's going to be multiple types of solutions. So how do we create networks or systems that can balance those two things? And similarly, then, how do we then manage the resources? And then, you know, something that else that often comes up is how do we connect over various terrains? It's one thing if we're designing a solution for downtown Boston. It's another thing if we're designing a solution for Gorham, New Hampshire. Right? So some of the related research and things that, you know, I'm interested in that also then fit into this are rural broadband communications, vehicular communications, wireless sensor networks, high-speed data communications, and finally some open networking protocols. So get in touch, talk to me. Those are my, you know, my 2 different hats in the websites where you can get some more information. I'd be happy to talk to you afterwards as well, or right now. Thanks.
UNH in New Hampshire actually has probably the densest sensor network of any state in the country in terms of monitoring our environment. And we've done, you know, this tremendous amount of work on understanding how forests and agricultural lands and developed lands interact with water bodies and what that means for people and society and things like that. So we've got this tremendous amount of work in body of work, and we do have this highly sensed environment, and right now there's a lot of work that's going on figuring out how to use that information, how to make sense of all that reams and reams of data, which is not easy. But one of the things also that's been of interest to researchers at UNH is what utility, what utility that has for society, and what kind of business opportunities might there be with those types of sensing platforms, from atmosphere to soils and water and agricultural fields and things like that. So I just wanted to put that out there and just to make that known that it's maybe a smart state instead of a smart town, but it still fits in that theme, I think.
Nick, in the venture world, I'm running into 2 different things at the end of the spectrum. One is, for example, devices that are highly complicated and are collecting a lot of information. So, for example, the example is healthcare using, for example, a monitor to monitor patient vitals relative to, let's say, a geriatric thing, or even monitoring drugs, for example. But what's happening also on the other end is really, really limited amount of information. So like ARFA technology could be readily and easily monitored. So all I need is a single character to identify a device in a specific location at a specific time. Very different application requirements in terms of your spectrum and stuff. Are you guys doing anything at that end, the ARFA end?
I personally am not. However, I think that's sort of related to the, some of the work I've done in the spectrum sensing, right? So if there's a lot of congestion, that may also be then very temporal. How do you find those little spots that you may need, right? And that then becomes a computational challenge as well, to find those in time and very fast and efficiently. Now, obviously, if you have something, I don't know what the ARFA is, but if you have something that's not necessarily sending a lot of data, it may also be low power, right? So there are some ways of doing that, concepts then of using some spread spectrum technology or a wide bandwidth at lower power.
Yeah. Okay. It's just that it's interesting that the demand is coming from both ends.
Yeah, it really is, and I've been going to wireless communications conference for many years, and a few years ago at this one that I helped organize, this past year the conversation was, what is 5G? Right? That was the conversation. And now 4 years later, everyone's like, we know what 5G is. It's everything, right? The concept of handling high bandwidth applications, but then also lower, maybe not necessarily discussed as low as that, but also low bandwidth applications as well. And you really don't need a sledgehammer for all of those types of things, right? So I think there's some new, in terms of the sensing applications, some new interesting technology that's coming out for connectivity that doesn't meet that demand of really high bandwidth, but can operate over lower or longer ranges as well.
Verizon mentioned 5G in the quarterly review that I just was at the other day.
ability to replace those rural areas where you can't get broadband access because either Verizon or Comcast or Fairpoint just don't want to lay the fiber out there. So you go with the cellular technology as a possible replacement for that. So that is something that they're definitely looking into as well. I'm just going to ask the Mandela question. What's RFID?
Radio frequency identification device. Basically, it looks like an inert device, but they're getting much more sophisticated because they can produce them on labels, for example, printing them with a printer. But it's an actual chip that's being printed on the label. So sometimes
like RFID?
referred to as thin film devices.
So is it like RFID? Same
RFID,
idea?
RFID. But the thing is, they're much, I mean, you're now talking about a computer.
Okay.
You're now talking about a computer effectively on a label.
Yeah.
So their ability to do a lot more than strictly project back a barcode designation, they now can project back intelligent information that they may actually have collected.
So
Sure.
I have a company that's doing that. It's an RFID company that's, the RFID is sending the information to a gateway. And that gateway happens to be cellular. So
Picking it up.
exactly.
So, this is all fascinating stuff. I mean, we're really only in the pre notion of an iceberg that might be tipped at some point in the future. There's so much to be done in the future. I'm
Yeah, I agree.
super excited about it. The question I have that I'm trying to wrap my head around is, you know, we can create. I have a startup that I'm working with that's you know Bluetooth, that's creating a mesh network that devices can talk to each other. That's really cool. What is being worked on? Are there standards out there? Maybe the IOL is working on this for devices that are not of the same thing to be able to talk to each other. When I have my self-driving Google car driving down the road that can communicate to all the stuff I'm driving nearby for any number of important reasons, is that an API? Is there people working on that? What can I know about that?
Yeah, that's
a good one.
It's a big challenge. It's a very
Yeah.
big challenge. You know, standards are designed for a number of reasons. One of them, so could be some competitive space, and different companies can make a product and have them communicate with one another. But your Bluetooth sensor is not going to talk to the Bluetooth connection, or not going to talk to the cellular connection in your phone, for example, right? I think, you know, one way we've seen around that is sort of the kludge where, you know, a phone, for example, has all those different radio systems inside of it. I think at some point, because, you know, right now I think it's hard for us to see, because we see, you know, this high bandwidth application and a low bandwidth application, and really the constraints and demands for how they work are so different, there's no reason to have the same kind of protocol. But I think we're going to see as we get to some point, outside of the special cases where there's, you know, I'm sending a bit of information versus gigabits of information, that you can have a technology platform that can be very dynamic, right? So one of the ideas is to have a very dynamic radio front end, right? So touch the microphone, sorry. So a dream of mine, something that was mentioned, that Maria mentioned earlier, is something called software-defined radio, where you have a radio system that can be reprogrammed. And it's kind of a neat thing to do in a lab, and I use it for my research because I can easily make this radio box in my lab listen to FM radio. I can then have it be a GPS receiver, and then I can have it be a Wi-Fi just by entering in some programs. But there's still a lot of RF front end. So I think as A to D and D to A processors get faster, you're going to still have a lot of those applications, but it's going to move right out to the antenna. So you're really going to be creating your modulation, and the A to D to A is going to put it right on the antenna. So you're still going to have this need to have different kinds of protocols, but it can be less, I guess, of a kludge where you have all these different things to do it, where one kind of thing can do it.
Josh, can I ask a quick question? You mentioned that company that's using Bluetooth with a mesh network. So what is that mesh network that they're using?
So I think
If you know.
Yeah,
just curious.
I have to ask them.
Yeah, I'm just curious.
So working with them more on the go-to-market and all that other
Got
stuff
it.
versus the specific technology. There's one other piece to that that it just made me think about. There's a company that's actually more in the Bitcoin space, but it just occurred to me this might be an interesting intersection as well. You know, the notion of tiny minutia transactions, such that my device can detect other devices nearby that might have capability that I need, and are able to auto transact to share that data or broadcast that data back out and in. It's a very machine world out there. Just plant that seed.
I think we'll take one last question, and then we can take say thank you to our speakers and have some.
Okay, so following up on what Josh said, I'm very concerned about standards, and I think what's really killing innovation in the sensor hardware space is the lack of a standard for them to communicate up in that stack. We saw the smart town stack. If there could even be just a standard for interfacing to the sensor to get the readings from it or have it send an alarm, and then a separate layer for gateway devices. So, as you're saying, wireless is a fallback to wired, for example. If the sensor developer could think about only innovating to that interface, and then you could, some other entrepreneurial companies could develop different gateways, the Bluetooth gateway, the upper end of that same interface, or the cellular gateway, the cable gateway, and so forth. That would allow innovation in the sensor space, and would also allow them to perhaps construct a tunnel, like this company in Dover. They're doing some energy monitoring. They want to go from their sensor through some kind of communication tunnel and end up at their application at the top. They would like to have someone else worry about how it gets between those two layers. And I think that's where you're going in your cellular offering. But without that standard right at the sensor level.
Yeah, there definitely is not a standard. There's no question about that.
They have to code to each stack, really. And Comcast wouldn't even want them. Comcast wants to own the whole stack, all the way down to the bottom.
Got it. Yeah,
So
it's not there yet.
Important.
It's the wild, wild west in a lot of ways. People are just doing whatever they can to get to go to market. And as Josh was mentioning earlier about, it would be great if they could standardize on that platform for the developers and make it all universal, but it's not there yet. Maybe that's a question for the Ciscos of the world and Intels and things of that nature at some point.
Well, everybody can join me in thanking our speakers today for
Yes.
their time and for...
Thank us. Thank us. Thank you.